Welcome to Veteach. Today we are going to discuss about the transform domain representation of convolution codes. So in this time domain representation, what happens? Here simple, by adding the sequences, by combining those two, we can get the time domain representation. But here the transform domain is calculated or evaluated simple by applying the polynomials. These calculations simplified by applying the transformations to the sequences. How the transformations can be applied to the sequences? Simple. These responses are represented by polynomials. That is the basic difference between time domain approach and transform domain approach. How we can generate a polynomial, how we can represent a polynomial already learned in linear block codes. Simple. Here the polynomial is g power 1p. In the previous representation, time domain representation, we can write g naught power g naught into p like this. So g power 1 into p, here g naught, g1, g2, g1 power m. Simple. With respect to the kind of representation, here p power naught, p power 1, p square and p power m. Polynomials with respect to the messages. So by multiplying the polynomial with respect to the generator matrix or generator representation, we can get the data. Similarly, this is for x1. For x2, with respect to the m1, m2, how the x2 can be represented is simple. G power 2 of p, g naught power 2, g1 power, here p naught, p power 1, not p power 0 is nothing but 1 polynomial, g1 square, p, g2 square, p square and so on, gm power square into p power m. That is the representation. So simple, two kind of polynomials can be expressed. First one, g power 1 into p, this is for x1 exclusively. The second one, g square of p, this is for x2. So in this representation, the value of g naught is with respect to p power naught, g1 with respect to p power 1, g2 p square, gm p power m. Here 1 is not changed. This is the output of the representation code x1. Here also g naught, p naught, g1 p power 1, g2 p square. Simple. Here also this is for x2. Here these kind of polynomials can also be expressed or explain any kind of sequences. Here the variable p is the unit delay operator. How the unit delay operator will take place? Simple. How the polynomial for message we can express it. Here m of p, simple. Here for the representation of x0 and x1 with respect to the g, here m of p message in terms of the polynomial, by multiplying those representations with respect to the message and polynomial, the final resultant equation will take place. Simple. m0, m1, m2, m and so on, l minus 1. Here the representation simple. How this is transformation, applying the polynomials with respect to the message in terms of the polynomial, finally we get 1, because x1 always depends upon g power 1 of p, x2 will always depends upon g square of p. That is the representation. So here with respect to each and every time message bits are different. So message with respect to the message bits, we can change the g power representation. Finally by multiplying those two, we can get x1, x2. In the previous, that is the time domain representation, the same kind of x1, x2 are get with respect to the direct addition. But here we can express those things in terms of the polynomial, and after substituting the message, the same kind of operation, which is nothing but modulo 2 operation, will be used, and finally we get the required data. Here simple, the above equations are the output polynomials of the sequences, xi power 1, xi power 2. Here the same modulo 2 operation rule will be used with respect to some kind of example. To obtain the generating polynomial for adder 1, the first generating sequence is 1, 1, 1. What is its code? Simple. Here the representation is g power 1 of p. What is the data, sir? 1, 1, 1. So 1 into p power 0 plus 1 into p power 1 plus 1 into p square. So what is the final equation? Anything power 0 is said to be 1 plus p square. With respect to the input gi power 1, the polynomial will be like this, 1 plus p square. Second thing, to obtain the generator for the kind of representation, this is given. So 1 into p power 0 plus 0 into p power 1 plus 1 into p square, anything power 0 is said to be 1, 1 plus this will be 0 plus p square, finally 1 plus p square. This is the data. So step 1, generating the polynomials with respect to message. How we can generate the polynomials with respect to message, sir? For the given data we can express like this. So two representations, finally 1 plus p square for 1, g power 1 of p, for g square of p, that is 1 plus p square. Second, obtain the message polynomial. Here this is the message representations. So how we can get m of p, sir? 1 plus mp plus m square p square, the kind of representation. Here the same, 1 into p power 0, 0 into p power 1, 0 into p square, 1 into p cube, 1 into p power 4, the same kind of representation. Finally 1 plus p3 plus p4. So for x1 xi power 1, simple, g power 1 of p into m1 of p. For xi power 2, g power square of p into m of p. First we generate this one, after this one by multiplying those two we can get what is x1, what is x power 2. Simple. The same time, mp with respect to the message in terms of the polynomial. Now determine the output of the adder 1, 2. So first one, x power 1 of p, what is g power 1 p, what is m of p. This is the representation. So this is already done with respect to 1 1 1. This is for the kind of representation message taken, this one. So by multiplying those two, finally we get 1 plus p square plus p cube plus p6. So the above polynomial can also be expressed in terms of the kind of representation with respect to the data, that is x power 1 of p, 1 plus 1 into p, 1 into p square, 1 into p cube, 0. There is no 0 operation, that is the p power 4 is 0, there is no p power 4, that's why 0 will be added. There is no p power 5 here, plus p power 4 plus p power 5, 0 0, that's why 0 into p power 4, 0 into p power 5. The same can be expressed in terms of the polynomial equation. So with respect to these kind of representations, 1 will be produced, no problem, p power 1 no problem, p square no problem, p3 no problem. What is the value of p power 4? 0. What is the value of p power 5? Because there is no p power 4, p power 5, that's why we assume it can be 0. Again p power 6, 1. So what is the convolution code we generate with respect to the g of p, m of p? Simple, 1 1 1 1 0 0 1. For the data, g of p is given, m of p is given. Again the same kind of representation added 2. In time domain, directly adding those two with respect to the modulo 2 operation, but here there is some kind of change in the way of generating convolution code, because each and every time we generate polynomials, after that we can multiplying those two, finally we get adder 1, adder 2 outputs. That is the basic procedure. Simple. Here g power 2 of p, m of p, g power p is already generated, m of p the same for adder 1, adder 2. Finally this one, with respect to, if this can also be expressed in terms of the polynomial, no problem. Finally 1 1, there is no p power 0, p power 0 is, there is no p power 0, that's why we can keep 0. P power 1 also, p square 1, p3 1, p power 4 1, p power 5 1, p power 6 1. So only the position p power 1 is 0, that's why the second bit is 0. This is adder 2 output. So adder 1 output will be produced, adder 2 output will be produced. So finally the resultant representations. What is the first combination, sir? This is the combination 1 1 1 1 0 0 1. What is the second combination, sir? 1 0 1 1 1 5 ones. So finally 1 1 1 0, third 1 1, fourth 1 1, fifth 0 1 0 1 1 0. This is the resultant representation. This is the resultant representation of adder 1 and adder 2. So For the data, this is the gi of 1, g power 1 of I, this is g power 1 of p, we can write the polynomial. The second thing, g power I2, the data is given, we can express in terms of the polynomial. Third, the message is given, we can express in terms of the polynomial. For x power 1 of p, by combining those two, and we can write expression. But next, x square of p, by combining those two, by comparing those two, we can generate the representation. So this is the transform domain representation of convolution codes. Very easy. How the transform domain representation is simple. We can express each and every term in terms of the polynomial, and after simplification we can get the resultant. But in terms of the time domain, we can combine, we can add the sequences with respect to the M1, and we can calculate the shifts. How many number of shifts will be happen. But in terms of the transform, simple, each and every time express the things in terms of the polynomial, and finally we calculate the kind of representation. Thank you.